Okay, so the second part, the second kind of sequence that we need to worry about this semester is geometric sequences. And they're a little bit different than arithmetic, but not much. And this is our learning target. We're going to be able to find the common ratio, write a recursive in an explicit formula, and then use those formulas to find missing values. Alright, so geometric sequence, what's the difference? Well, we know, for one thing, that if we examine this first one, the first one increases by 12, and then the next one increases by a lot more than 12. So we know it's not an arithmetic sequence. So the next thing we should try to see if it's a geometric sequence, and a geometric sequence is one where it's multiplied by the same value each time. Instead of being added or subtracted, is being multiplied. So if you think about it, I mean, the person who's probably a little sharper than I am is going to notice that this is, if I multiply by 4 each time for this next sequence, that's how I get the next number. So in this case, the common ratio is going to be 4. Now, if I hadn't noticed that, or if it was not a real clear number, what you can do is you can take the second term. I'm going to use G to denote a geometric sequence. You can use A. Some books, every book does it differently. So, but if we take the second term and divide it by the first term, that'll be some number. And then to check and see if that number holds, that common ratio holds, take the third term and divide it by the second term. And you might have to do this more than once. But if you're doing this a couple of times and it's looking like you're getting the same number each time, then that's a geometric sequence, and that'll be R. So if I could have done 16 divided by 4, and notice that was 4, and 64 divided by 16, and notice that was 4. So that would have told me that my common ratio was 4 that way also. Okay, for this next sequence, it's not as nice as this other one. So what we can do, though, is we can try that trick where I took, well, let's see. If I take negative 2/3 and divide that by 1, that's going to be negative 2/3. So there's nothing spectacular there. But if I take 4/9 and then divide it by, notice I'm writing it a little bit different. It's the same math, and then what I'm going to do is take the reciprocal and change it to multiplication, right? So let me see if I can slide this over. So 4/9 times negative 3/2. I took the reciprocal, and I like to do this cross canceling, I call it. So what happens, I get negative 2/3. So I think that's what the common ratio is. If I multiply by 2/3, I get the next number. So let's see if that is what happens. So if I take 4/9, I'm going to multiply that by negative 2/3. That's going to be, let's see, no cross canceling, but that gives me negative 8/27, and that does check. So that tells me the common ratio is negative 2/3. Okay, so for this third one, again, I'm not seeing anything clearly. I know it's decreasing, so that's good. So let's try this way. Let's take 600 divided by 750 and try to simplify that equation. Well, let's see. I know that 10 goes into each. Let's see what else. I know 5 goes into each, so that's 12 over, what is that, 15, and then 3 goes into each. So that's going to be 4/5. So it's looking like the common ratio is 4/5. Let's check. Is 600/1 times 4/5 the same thing as 480? Well, let's see. 5 goes into 600 120 times. 120 times 4 is 480, so it looks like the common ratio is 4/5. So we're going to be able to write the same kind of thing, now that we know how to find the common ratio. The recursive formula is very similar to the arithmetic recursive formula. I'm just going to write G sub 1 to denote the first term. and I might slip up and use A, folks. It doesn't really matter what you use. And then to get the next term, I'm going to take the last term that I used, and I'm going to multiply it by the common ratio, R. So that's the recursive formula. To get the next number, you multiply by that common ratio. The explicit formula is a little different, but what you're going to have is you have your first term times the common ratio raised to the n minus 1, because you don't want to multiply by the common ratio for the very first terms. That's why we use, let's see, if I was going to find the first term, use a formula to find the first term, I would want to make sure that I just had the first term, and 1 minus 1 is 0, so r to the 0 is 1, so that g sub 1 equals g sub 1. Okay, so there's the explicit formula for a geometric sequence. Here's your recursive formula. So to use that very first sequence that we found, we knew that r was 4. So to write the recursive formula, the first term is this 4. And to get the next term, I take the previous term and multiply by 4. So the explicit formula for this sequence would be the first term is 4 times the common ratio of 4 to the n minus 1. And I could use parentheses here if I wanted to. Okay. For this one, we knew the common ratio was negative 2/3. We know the first term was 1, so g sub 1 equals 1. To get the next term, I take the previous term and multiply by negative 2/3. Now to get the explicit formula for this one, you take your first term, which we really don't have to do. Negative 2/3 raised to the n minus 1. And that's certainly one form to write this. Okay, for this one, we knew the common ratio was 4/5. So the first term, not the nth term, the first term is 750. To get the next term, we take the previous term and times that by 4/5. So the explicit formula is the first term of 750 times 4/5 to the n minus 1. And that's that explicit formula. So here's one the textbook authors wanted us to look at. So to me it's looking like I don't know what r is, so I'm going to do negative 3/1 and 9/-3. In both cases I get a common ratio of negative 3. Okay, so then I know they want me to find the 11th term. So my first term is 1. That common ratio is negative 3 to the n minus 1. That's my explicit formula. So if they want me to find the 11th term, 1 times negative 3 to the 11 minus 1. So 1 times negative 3 to the 10th power. Well, I know when I raise a negative number to an even power, it turns positive. So since I don't have a calculator and I know 3 to the 10th is going to be a large number, I'm going to leave that. The 11th term will be 3 to the 10th power. Okay, so a series. How do I find the sum of a geometric sequence, or how do I find the value for a geometric series? So we're going to look at this formula, and a lot of things are the same. This problem here is using that summation notation. I know that my common ratio is 3, it looks like, because I'm multiplying by 3 each time. To find the sum, I guess we got to generate our sequence. So when k equals 1, that's going to be 2 times 3 to the first, which is 6. Now notice with this formula, I don't need the last term. I just need the first term, the common ratio, and the number of terms. So to get the sum of the first 12 terms, I know it's 12 because that's the top number, I'm going to do 6, which is the first term, times 1 minus 3 to the 12th power all over 1 minus 3. Okay, and then this is certainly a calculator value. So when I calculate this on a calculator, I'm getting 159, let's see, 4320. So what is that? 1,594,320. Reminiscent of compound interest. And what's a sequence problem without a word problem? So let's see. So it's bouncing. It bounces up, and it says 2/3 of the previous height. Okay, so this tells me the initial height's 27. Each time it's only 2/3 as much. So I could write so we know that our first term is 27. We know the common ratio is 2/3. So let's use that formula to find the 10th time. So the sum of the first 10 terms. So we can do the first term of 27 times 1 minus 2/3, all raised to the, what is it, the 10th power, all raised to the 2/3. And again, I think I'm going to use a calculator to evaluate that. So my calculator is telling me that by the time it bounces 10 times, this ball will have traveled 39.798 feet, I guess, or is it meters? Now, one thing that's different about geometric sequences is we have this idea of what if we want to add up all the terms that a sequence will ever produce. Now, with an arithmetic sequence, that'll either keep going to positive infinity or down to negative infinity, so it'll never reach a sum. You'll learn in Calc 2 or 3 about whether a series converges or diverges, and we really don't need to worry about that. Just know that if it converges mean that it does approach a sum, and it diverges if it doesn't approach a sum. One way to tell if a series is going to converge or have a sum is that each term is going to be smaller than the previous one. If it's growing, it'll never converge, or it'll never have a sum. This one certainly is, because what's happened is each fraction is getting smaller and smaller and smaller, and eventually it'll be so small it'll be practically zero, so you're adding on nothing. Okay, so that's what this is all about. So for these two sequences down here, okay, I'm noticing that for the first one I'm adding 3, then 6, then 12, then 24. This is never going to reach a sum because I'm always adding on a larger number. If we're looking at the next one, I see some alternating going on. It's going back and forth between a positive and negative, but the numbers are getting smaller and smaller and smaller. The numbers are approaching zero, so this one will probably have a sum. Okay? Something you'll learn about in Calc right off the bat is limit expressions. Well, we write one here. But this says the limit as n approaches infinity. In other words, as I add on more and more and more numbers, the limit of this series will approach some value, some number, I'll use L for the limit. Okay, so first one doesn't exist; it'll never approach a limit, and I know that because it's growing. The second one probably will approach a limit because it's getting gradually smaller and smaller, or close to approaching zero. So what we're going to do is decide on the common ratio for part B. So I have negative 4 over 3 divided by 4 over 1. So that's negative 4 over 3 times 1 over 4. That is 1, 1. So my common ratio is negative 1/3. So that means since that the absolute value of that is less than 1, it'll have a sum or a limit. So the formula we're going to do this is simply you take your first term and divide it by 1 minus your ratio. And that'll be your sum. So since my first term is 4, I'm going to do 1 minus negative 1/3, which is 4 over 4/3, and let me move this down a little bit. So that's going to become 4 divided by 4/3, which is 4 times 3 over 4. And that tells me this series, if I keep going and add it on, will approach 3.